Hello, welcome to Narcolepsy Pumpkin. I'm Andy, and this episode is at the request of one of my viewers. So, I've had a request from Vienna, aka Lauren Ann 69, for a video on Object Calisthenics. And I thought, why not? Object Calisthenics. Or at least my take on it anyway. Okay, so let's address the elephant in the room. I'm not strictly someone who conforms to Object Calisthenics. There are some commonalities between Jeff Bay's original ideas and the way and the style I write code. To make sure I do justice to Jeff, I'm going to look at Object Calisthenics in its purest sense before looking at how I apply something that is similar when writing functional C#. So to start, let's blast through the history, its relevance, and some examples along the way.
Hello and welcome to Narcolepsy Pumpkin with me, John Peel. In today's episode we'll be mostly looking at Object Calisthenics. It's not that I've particularly decided to channel my inner John Peel, it's just that I have a cold, so I do apologise for any gruffness in my voice. So to give a little bit of background, Object Calisthenics is a concept coined by Jeff Bay to gain much cleaner and easier to read code by obeying 9 quite simple rules. This was born out of his observation that object-oriented languages often led to quite nasty-looking code. In writing this paper, and to help him to explain these rules, he gave himself a challenge of writing a small program, and then refactoring it using these 9 rules, and in his words, a stricter coding standard than he'd ever used in his life. The rules of Object Calisthenics. The first rule is there should only be one level of indentation per method. This is to avoid huge 500-line functions that are really hard to understand. The second rule is don't use the else keyword. This goes to some degree hand in hand with the first, because if you've removed indentation like if statements and loops, then there's unlikely to be a requirement for an else. The third rule is wrap all primitives and strings. Now I find this is one that gets a little over-prescribed. My interpretation is probably slightly different from others, in that I don't feel it's necessary to wrap primitives and strings just for the sake of it, only where the true intent is improved by doing so. Rule number 4. First class collections. Any class that contains a collection should contain no other member variables. Each collection gets wrapped in its own class, so now behaviours relate to the collection have a home. Now most of this is really covered in C# by link, so the link queries for select and so on that are extensions of the IEnumerable interface, and this goes well with my C# functional style of programming. The fifth rule, 1 dot per line. Now again, this is applied with a little bit of pragmatism by myself, in that I don't tend to have more than 1 dot per line, but I do tend to have lots of dots in my statement, which kind of goes against part of what this rule was about. The difference being, where I've got multiple dots, I'm actually calling extension methods in a functional pipeline, as opposed to a secondary depth of object. Looking at the rule in its purest form, you'd be looking at calling a method or looking at a property that is part of a sub-object. So having a property that is an object and then looking at a property or method of that object. Now this is something that really did get covered in the Pragmatic Programmer. Rule 6, don't abbreviate, is really one that's close to my heart. I am a big fan of using as descriptive titles, variable names as possible, and try and make them sensible for the scope you're working in, which goes hand in hand with Uncle Bob's clean code philosophy. Where the scope is wide, the description is long. Where the scope is short, the description can be shorter. Again, it's a pragmatic application.
Using abbreviations for things that are common in English language is okay,
but absolutely avoid things like Hungarian notation and using abbreviations for things that are of a technical nature. And rule number 7, keep all entities small. A relatively simple context that means that you've got to keep your class sizes down to somewhere under about the 50 line mark. So a class being about a screenful if you're using a font you can read without binoculars. Some people find this very difficult to do because it means extracting quite large chunks of functionality out into separate classes and building out dependencies. Some of that dependencies then can be mitigated by using solid principles, but the key thing is to try and group things together that are going to change for the same reason. So if they've got a logical sense of the same behavior or goal, they probably should be sat together. How you determine where the lines between classes are and how they are actually separated, again comes down to a fairly pragmatic approach to changing the code. Rule number 8. No classes with more than 2 instance variables. Now, some people will probably find this fairly limiting, but there's nothing to say those instance variables can't be another class. And last but not least, rule number 9. No getters, setters, or properties. Again, this is one that people will find quite hard. How do you have data without getters and setters?
Well, in this context, the inner state of the object isn't something we're looking to expose, but it is, however, something we're looking to act upon and potentially query in part. Therefore, getters and setters for the inner state would be inappropriate. If you'd like to read Jeff Bay's original paper, with all 9 rules explained in full, that can be found on my blog using the URL on screen.
Technically, these apply to any object-oriented language, but most of the examples you'll find are written in some C-style language, such as C++, C#, Java, and JavaScript, though the ink is still a little bit wet on its object-oriented credentials. So let's look at some examples.
To look at Rule 1, I've paraphrased the original document code into something that C# understands, and I've added some supporting variables around it so that it compiles. So simply put, the first rule where we're looking to only have one level of indentation means that in this particular piece of code we have a problem initially here and here, where we've got more than one level of indentation. The simplest way to solve that is to refactor this out into a method. We'll call that getRows, and that's going to act on the buffer that's passed in. In this case, it's just a string builder. So that's removed the indentation from here. So there's now no longer any problem with this function But unfortunately, we've still got a problem here. So we've got to do the same thing again by extracting another method. Call that getRow. We can then remove the braces from there. I prefer to have it on another line. So, to try and illustrate rule 2, I've created the following little class. The first simple decision, the easiest way to get rid of the else statement, is to return early. Not everybody will actually agree with me here, but this is how I would do it. Then we can simply remove the else statement from the equation entirely. So you can now easily see that this last statement here is the default, and here is the do something, and it will return early. A very similar approach can be taken to the second function in this. So for the first if statement, we can easily return early. This then removes the need for the else as part of that if statement, and we can do the same thing again, which in turn removes the need for the second else. Where we've got a nested if statement, we can take the function within, take the code within, extract that as a new method, we can then make that, we don't need to make that return as it's the last statement. We can remove the braces, and then here we can do the return early and remove the else. So, to look at rule 3, wrap all primitives and strings, I've created this small example. Now, my interpretation of this rule possibly doesn't fit with everybody else's. So this is a function that is very simply passing two string variables in. So we've got one string here and one string here. Now, for instance, if you refactored the signature of this function so that the file name was the second parameter, so basically just switching these two around, this would still compile as it stands with no modification. So the idea of wrapping the primitives is to further show intent. And we can do that by creating a specific interface, abstraction, or class that represents the file name and another one that represents the log line, so the two can't be confused. In this scenario, to do that, I would do something along the lines of creating an interface for we'll go with lowercase in there, file name, and one for I'm going to leverage some of the nicely inbuilt functions and create an interface. So that works fine. But then we'll need to do something similar to that. We then need a so it gives me two interfaces so I can see the intent. Obviously my code here now is broken. So if I extract that into a variable, just got the file name for the time being, and if we extract that into a variable, now we can now use the magic of Shadowquack if I install it first. I can now simply do uppercase in that. Let's change that. Random bubble in there. How did that go there? There we go. Almost. Extra squirrely bracket. So there we go. That shows there's a definite intent, and it also means that the signature is unique. If you swap it round, it's not the same. This also works very well when using extension methods, because it allows you to say that this extension is specifically for a file name or specifically for a log line, as opposed to it being based on the generic string, meaning that the intent is further identified, and it also means that you're less likely to be offered that extension on the wrong thing. To a large extent, Rule 4 is pretty much covered off by using link. Because any collections we can use link functions, and they give much better control over collections and immutability built in. But if you do have a need to do anything with a collection, then this still stands. Your collection should be encapsulated completely. The easiest way to cover this off with any new requirements for functionality around an IEnumerable would be to create an extension method that does what you need. So in my initial introduction, I touched on Rule 5 dot per line and my interpretation of it. Just to be clear, the original rule is as follows. Sometimes it's hard to know when an object should take responsibility for an activity. If you start looking for lines of code with multiple dots, you'll start to find many misplaced responsibilities. If you've gone more than one dot in any given line of code, the activity is happening in the wrong place. Maybe your object is dealing with two other objects at once. If this is the case, your object is the middleman. It knows too much about too many people. Consider moving the activity into one of the other objects. If all those dots are connected, your object is digging deeply into another object. These multiple dots indicate that that you're violating encapsulation, try asking that object to do something for you, rather than poking around in its insides. A major part of encapsulation is not reaching across class boundaries into types that you shouldn't know about. The law of Dimitri, only talk to your friends, is a good place to start. But think about it this way. You can play with your toys, toys that you make and toys that someone else gives you. You don't ever play with your toys. So if we take the example that's provided by Jeff Bay, you can see that there's a loop here. And this loop is taking details about these other two subclasses and acting on their internals. All this code does is move the responsibility for owning those actions onto the class that owns the data. So what's actually happened here is that this function here knows exactly everything about this class and this class. So the representation here, current, is one of these. And then we're using substring because we're knowing that this is a string. So the fact that this is a string, you can consider to be an implementation detail. All this actually wants to do is convert the current location within the representation to a string. So that's achieved at this side by making the representation a private internal detail and then providing functionality that returns the character. And we've also got an add to function that's appeared here, which encompasses the ability to append it to the buffer. So this simplifies it by we're saying add to string buffer inside this location, and that uses the current add to and buffer function, meaning that this piece of code originally doesn't have to know anything about the implementation of piece. All it has to do is say add it to the buffer. You can definitely improve this piece of code by having slightly better named functions. Also, I would advocate that you could separate this into completely separate projects, completely separate classes, and also introduce some element of abstraction. Another thing to note here is that this probably makes more sense if you actually extract this. So Control Shift Alt and left to pull that out, and again Control Shift Alt left to pull that out. These can then be put into their own files. So piece we can make. That can be public. Location. You can now absolutely see that this function only knows about location, has no idea about the piece class at all, and doesn't need to. Rule 6. I think I've pretty much explained that in full in the introduction to these rules, but just to go over it again, what you're looking to do is name things correctly for their context. Technically, this context has been repeated here. So ideally, because we know we're part of board, that would make sense to be representation. These, location L, a very small scope. You can see that location is L. It doesn't live beyond this for each. Therefore, using L is okay. But if you did want to extend that to B location, there's no harm in that. What would be unacceptable or deemed unnecessary is to start calling that board representation location, because you're repeating more than one level of context. Also, when naming variables, avoid using the Hungarian notation, and try and use words in full. Using abbreviations can make it very difficult to read, because if the person doesn't understand what the abbreviation means, the context could be misconstrued or its purpose misunderstood. So rule number 7, keeping all entities small. 1 is using the partial class, as I have done here, which means you can split a single class into several files, coupling together parts of that class that are supposed to do one thing and would change for one reason. I would only recommend doing this if you've actually got some form of interface segregation. So for instance, if you had a board class implementation that was made up of several sub interfaces, you can define one partial class for each interface. An example of this would be do something similar to what I've done here. So we've created an iBoard representation interface, which is implemented against the board class, which is a partial, in this file. I've then taken another interface called iBoard, which has the getBoard, and that is implemented in the original board class. So that's a partial class that this file implements iBoard. The board class itself now implements both these interfaces, which can be separate, as you can see here. You've got one class, but each of the implementations of those interfaces are in separate files, though the class itself is one thing. This allows you to split down the functionality of a class without actually breaking the class apart into separate files that have things that change for the same reason. It also means, by having this level of abstraction, that you can create things that act on or use parts of that class based on the interface, as opposed to the whole concrete class. Rule number 8. No classes with more than 2 instance variables. Where you're using an object-oriented approach, an object encapsulates both the data, a state, and functions and methods that act upon that state. Therefore, you should only really have one state within your. Therefore, a limit of 2 instance variables should be perfectly adequate to represent the state. The example decomposition of Rule 8 given in the paper is as follows. So given the initial class, name, having first, middle and last, that can be decomposed as follows. So what we're going to do is take the last name here, and that turns into a class here called surname, which only has the family name in it. The class name still persists and is here, and these last two, the first and middle name, are decomposed into a single class that contains a list or enumerable as strings, and those are the given names as represented here. All in all, this means that none of these classes have more than 2 member variables to worry about.
So rule 9, no getters, setters, properties, pretty much follows on from the previous rule 8, in that you have complete encapsulation, and if your encapsulation is around a single state, then there's no need to have a get or set. You've just got functions that tell that object what to do. The only thing that I would tend to do differently in a functional style is separate those functions that act on the state from the state itself, leaving data completely separate. Anything that acts on it returning a new instance of state rather than mutating what's there. And that pretty much concludes Object Calisthenics, and these are the foundation of clean code as it stands today. And much of this practice is encapsulated in solid principles as well, with things like single responsibility, dependency inversion, allowing us to decouple code into smaller working parts. So to take these examples and refactor them as far as I possibly could, in a kind of functional manner, I would probably do something like the following.
So, if you found this video useful, interesting, then why not comment and, by all means, make a request. You never know, I might make you a video based on what you're looking for. But thanks for listening, and please click on subscribe and click on the bell to get notifications when I post new videos.